Now notice that the Rossland mean opacities is a weighted average over the inverse of the opacity. It means that you're going to have a higher weight whenever the opacity is small. That means for low opacities where the gas is more transparent. So the Rossland mean tends to favor the transparent wavelengths. That means that is the transparent wavelengths that are dominating the flux. The Rossland mean opacity controls the transport of radiation. Now there is another gray opacity that is useful, which is a Planck mean, which as you can imagine is the very opposite. It's going to give high weight to high opacities. Indeed, the Planck mean, we call it kappa p, is the opacities weighted in this way, the Planckian weighted by the opacities. So in contrast to the Rossland mean opacity that favors transparent wavelengths and thus controls the radiation flux, the Planck opacity is a weighted average that favors high opacities. So the Planck opacity is the opacity of choice for describing processes that, when absorption and emission are important, because these are frequencies of high opacity. But whenever you are interested in the transport of radiation, the Rossland mean is the one of choice because it gives a weighted average to the smaller, to the lowest opacities, where the gas is more transparent to the radiation.